Hello, everyone. My name is Carlos Siches from Lima, Peru. Thank you for joining to this new episode of EncoraTalk, enhancing data quality for better decision making. In the next 30 minutes, I will guide you through ensure data quality in our data pipelines, in our business metrics. We are going to see a real world case. We are going to see as well a demo using this tool. A little background about me. I've been working here in Encora for around 3 years as a data engineer. I had the chance to participate in different data projects using different cloud technologies. From my experience and my perspective, is the most important part and the most challenging part is ensuring data, ensuring quality in the business metrics. Okay, let's get started. Why organizations need to invest in data quality? Let's answer that question with another question. How bad is bad data? According some research company, poor data quality costs organization around $13 million every year. Almost 60% of organizations don't measure the annual financial cost of poor quality data. 44% of the respondents indicate that having poor data quality can result in extra time spent to reconcile data and extra costs for the business. According to Harvard Business Review, poor data quality costs 10 times as much to complete a unit of work when the data are flawed in any way as it does when they are perfect. And only 3% of company data meets basic quality standards. All that cost is segregated in different directions: poor decision, missed opportunity, frustrated customer, and poor data quality damage our reputation. Okay, when we start a data project, normally when we talk with data teams, they mention that they apply some data quality for some specific data set or for some specific fields in the data set, but they apply that in an isolated way. But nowadays is not enough. Nowadays, organization demands a life cycle approach to ensure proper control. Um, let's see data quality life cycle. First, it's important the discovery part, which is we are going to gather information about the metadata of our data, which is important because it is the starting point to know if the data set change or not change. The second phase is profile the data. It's a good technique to identify if the data that we are going to work is complete and accuracy. The third phase is the rule definition. Is the technique which help us to define rules for the data source, to define rules for business metric. Monitor, as I mentioned, is data quality is not on-demand process. Data quality now we need to check continue constantly. Remediation, if we found issues, we need to reconcile the data of reprocess if the data was already processed. And reporting, we need to, that is the last phase. We need a tool which help us to check how many issues we found, how many issues we resolved, etc. Okay, is there a tool that can address most data quality requirements in pipelines? The answer is yes. We have different tools in the market which help us to start applying data quality in our data sets. From my experience, the two aspects that the data quality tool need to cover is easy, user-friendly, because we need to get results very quick. The other aspect is the data quality tool need to cover different use cases. Let's see in detail some aspects which are important for me. Is the tool should be multi-source compatibility. The tool should offer different connection to relational database, connection to unstructured database, semi-structured database, in-memory data, such as data frames or Spark data frames, flexible, adapt for different use cases, batch processing, stream processing, change data capture processing. Integration is integration not only with cloud environments, integration with on-premises environments. It should be user-friendly, easy setup, easy configuration, easy management, uh, automation, enable rules definition quickly, and automatic execution, monitoring, schedule validation. The tool need to offer or deliver inside every day. Okay. Great Expectation is an open source data quality tool that help ensure data accuracy, consistency, and reliability. Great Expectation cover the end-to-end data pipeline. It and the key feature of the Great Expectation is automation, is integration with our pipelines, support multiple data source, bring clear and actionable validation result, and is scalable and flexible. Okay, let's see a real world case where we use Great Expectation. First, let's get know the customer. One of the Encora customer is a marketplace which offer a platform to sell and buy second-hand articles. It's a very big data ecosystem. It's a petabyte data ecosystem. They move terabytes of data every day. They have multiple business data teams, and they connect with multiple databases such as Google Analytics, MongoDB, and third-party APIs such as Play Store and App Store. And when we start in this project, the main objective of this customer is increase the total number of the new user and the traffic generated in the platform. Okay, when we talk with the business team, it was very important to understand that what are the symptoms and what are the root case, because normally we attack symptoms. If we attack symptoms, it means we are not we are going to have only temporary solution and no ending supporting. So when we talk, they mention we have problem with our business metrics. The business metric is not accuracy, is inconsistency, or is incompleted, or outdated, or is irrelevant, among other problems. And when we follow the path of the symptoms, we discover some root causes. The root cause is related to multiple data teams try to fix some problems with their own rules, with their own logic. It means they create isolated data sets. For that reason, the different business metric report different numbers. We have no understanding of the data source, and we don't have the control. We don't know if the data source got outdated or not, if the data source changed or not, what is the method of persistence of this data set. We don't know, they don't know much about that. Let's see with an example what we discover in this customer. We are going to bring to the table one of the entity, which is the subscription entity. Subscription is the same definition that we know in streaming platforms such as Netflix or Disney. They offer free trials for limit period of time with the important features of the platform. But after the free trial ends, they need to pay the subscription. As I mentioned in the last slide, the important objective for this customer is get new users, and these new users generate traffic. So for that reason, this entity became very important because the business metric from this entity is the total free trial subscription. The total free trial subscription tells you how many new users got engaged with the platform. The total conversion not only got engaged, the total conversion tells you what are the how time they are spending in the platform in terms of months. If they got engaged to pay a subscription. Uh, I don't write another metric, but we have the total retention, which is the number of subscription with a particular customer have, how many months they spend in the platform. Total revenue, financial information, very important. The total cancel subscription. What are the data sources involved for this entity? The data source are the App Store and the Play Store, third-party databases. What are the symptoms with these metrics? Well, subscription reports on daily basis, weekly basis, and monthly basis became unreliable. Display, they display incomplete data. They display a high number of null values and display a lot of inconsistency. For example, inconsistencies like we have 10 free trial subscription, but the total download it's only 5, for example. It's inconsistent. We lost the integration with our user database that affecting the execution of A/B testing experiments. The attribution models start to fail because subscription database no longer send information about which feature trigger the subscription. All those are the symptoms. But let's follow the path of the symptoms. What we identify? We identify the data source, schema change. How we determine that? Well, we can see in the data missing values due to deprecated columns, or for example, one particular columns change the data type. Before they send a string, now they send to JSON, and the process that didn't support that part. We stop receiving data that allow you to connect with the user database. It happened, for example, for restriction from the USA restriction. iPhone and Apple stop sending that information. We identify late arriving data. They send that information on a daily basis, but sometimes they have some delay issues. For example, they delay 2 days, 3 days, even 10 days, almost 2 weeks. They have another problem when the month change from January to February, for example. They don't send, for example, the last day of the previous month. And the process, our data process or the process of the customer wasn't prepared for that scenario. Another thing that we saw is the level of granularity change. Before, In the past, those applications only send information about the subscription when in the month that happened and the user ID. But now they start sending extra information. For example, if the user has some issue to pay the subscription, they send that information. If there are some notification about renewal, they start to send that information in the same API. It means the level of granularity change. For that reason, the report sometimes show duplicated information. Okay, this is the root cause. According to that, it helps us to determine an assessment for external data source, apply some controls to check if we have if them in the moment of the process we saw or we don't have fresh data. This is late arriving data to control late arriving data. If if we determine what is the granularity, we start implementing controls to review if we have duplicated information. For some important columns for us, we put some null controls to determine if that value if that column is bringing new values. Mm, Okay, this is the assessment for the external data sources. Um, how to implement data quality assessment in Great Expectation? Okay, before that, let's check a little bit the components of the Great Expectation. It's a very simple tool. We have five key components. One is the data source. This is the database representation. The data asset is the table inside the database. Expectation are the rules that we are going to define for that specific table or data asset. And validation is the process which gonna take the rules and run against the data and the results, which is gonna give you if the if that particular asset for this day pass the validation or not. This is the typical workflow to start introducing data quality layer in our data pipelines, specifically in data sources. First, we need to connect the data. Second, create the data asset. Third, create expectation. Fourth, validate the data. And five, review and share results. Very simple. Okay, let's see a demo, but before that, we are not going to use a customer database. We are going to use a very known data set in the data world provided by Great Expectation, the NYC yellow taxi trips. In the demo, we are going to cover the four first phases of the data quality lifecycle: discovery, profiling, rules, and monitoring. The rules or the controls that we are going to define is controls for late arriving data. We are going to, to make the difference between the current time and the most recent pickup time. Duplicated record. We know in this dataset the ID is the lowest level of granularity. And if we have repeated ID in the dataset, it means that dataset has duplicated data. Control null checks. We are going to choose one specific column, which is the drop of borrow. If the drop of borrow mustn't be null if the pickup borrow is not null. We are going to establish a condition. Okay, okay, let's see the demo in the tool using Great Expectation. Okay, this is the tool. It's very simple too. The first thing that we are going to connect is connect with the Postgres database GX demo data. As you can see here, Great Expectation can identify quickly what is the database and can identify the set of tables inside of that database. We are going to we are going to choose NYC taxi data. If you see here, we have a check for the text schema change. If we click on that, we are going to create our first expectation about if the schema change, see if the schema change or not. Let's click on that and let's add it. Well, let's go to the data asset. If this metric we cover until here the first phase of the data quality life cycle, which is the discover. The tool can help us to determine the columns, the type of the columns very quick. If you remember, the second phase of the data quality life cycle is profile the data. And if you remember, profile the data is a technique which helps us to get to know the data. And in a first view, we can see if the data is complete and accuracy. Let's see how it works in Great Expectation. Profile data. Okay, it was very quick. What is the size of the data of the data set in terms of row count? Is 100 miles. Let's see this number, this statistic number. For example, I can determine if data set the data set is not complete because we have a percentage, we have nulls for some column. In this case, it's for drop of borrow and pick up borrow. So it helps us to determine the data set is not complete. But, and for example, let's see fair amount. We have negative values. It means the data set is not accuracy because they are having bad data. If we check, for example, the mean and the median for this column, uh, it brings the idea that we have outlier as well, positive outlier, because we have amount almost $500, which is looks like it's not correct. About the passenger count, we can identify that we have zero, the total number of passengers, which is an error. Something that we know about this data set, the taxi only can support only 6 passengers, so I have incorrect values as well here. Yeah, trip distance, we have 0 miles, which is not correct. So for that reason, profile the data is very important because it gives you the possibility to know very quick your data and determine if the data is complete and accuracy. And it brings you the possibility to define the first rules to start attacking this kind of issues. Okay. Sec. Okay, let's go to okay. Until here, we cover the first phase, discover, and the second phase, profile the data. The third phase is the rule definition. So let's go to the expectation part, which are the rules in Great Expectation, and let's define. The first rule, the first rule that we are going to define is related to the duplicated data. So let's create it. Go to the new expectation. Is the category is uniqueness. The column values inside the dataset should be unique. What is the column that we are going to evaluate? Is the ID for the 100% of the cases, no condition, and save it. Okay, we define for the new expectation that we define, we are going to see here. Something happened here. Okay, the expectation was probably we need to refresh the page. Okay, we have two expectations until here. We have a schema validation, and we have the control of duplicates. Let's create a new expectation. Remember, is to check null values. So it's related to completeness. And we say the column values mustn't be null for the column pickup bottom, for the column drop of bottom, sorry. And the condition is when pickup bottom is not null. Yep, save it. Here you can see we create a new rule for this data asset. And the last one is related to the fresh data. Let's create this new expectation, and we are going to use for that custom SQL. According to the documentation of create expectation, that definition is gonna fail if the query return data. The syntaxes that we need to use is related to the connection of the database that we have. In this case, it's Postgres. So let's put a name here. Is fresh data, for example. Okay, let's put this here. Say let's from bash, and we are going to get the max pickup time. Let's put a name here. Most present pickup time. Okay. Okay. And now after that, we are going to put a condition if the current timestamp difference between the most recent most recent time, it should be greater than in Postgres struct to timestamp. The difference is an interval 1 day. If we have if we get data, it means we don't have no fresh data. Okay, yeah, let's add it. Yeah, until here we cover the three phases of the data quality lifecycle. Discover, we cover profiles and rules definition. Okay, let's validate that. Just to mention, we can schedule this validation. For example, every 24 hours, and the start time should be 7 or 1 p.m., 2 p.m., the time that works for you. Let's validate it. Okay. Okay, let's see the result, validation. Table level expectation runs well. It means we don't have any changes on the schema. Drop of bottle. So it passed the validation. It means we don't have null values when pickup bottle has value, which is correct, and we don't have duplicated records. So it passed. Let's check the part of the SQL. And here uh, we don't see the profile data, but I know that we have data until 2022 3rd January, if I'm not wrong. Let's change a little bit and see how easy it is to define a new rules or upgrade the rule. Go to the expectations, go to the rule that we want to change, and remind today is 2022, January 3. Remind this and save it. And now let's run it again the validations. Okay, validation, it's already complete. Let's go to the validation. And now you can see all the validation pass. So until here, we cover until the fourth step of the data life cycle. We cover the part of the discover, we cover profile, we cover the definition and monitoring. We are checking what is happening when the if we check here, we are able to see what day the the validation pass and what day the validation not pass. So far is the demo with the tool, and now we can go next with the part of the question and answer. Okay, if there are any questions. Okay, does your expectation only support data sources like Snowflake, Postgres, and Databricks? The answer is no. I know when I did the demo, we only see the connections for those databases, but to integrate more connection, we can use the complement component of this Great Expectation Cloud. It was Great Expectation Core. Great Expectation support multiple data sources. It seems like a Great Expectation only provide a summary of whether check pass or fail. Is it possible to view detailed result? Yes, is it possible? Great Expectation has a number of um, many APIs where we can check what are the values which fail. You can uh, get that information with GXcore. It's very easy to use as well. Yeah, but we can get the data. Even we can override some methods. We can start applying data cleansing as well, according to the result of the validation. Can Great Expectation integrate with notification tools such as Slack or Microsoft Teams? Yeah, the answer is yes. We can do all those things that you're asking with GXCore. It's very easy to integrate and we can share results. Even here in the presentation, I am receiving notification and in my email about if the validation pass or not pass. Yeah, but we can integrate with many different tools. Okay, okay, team, no more question. Thank you again for joining to this Encora talk. If you want to know more about Great Expectation, data quality assessment, or other stuff related to data, you can find me in Encora official channels. I am Carlos Siches, and thank you for joining to this Encora Talk. Bye. Have a great day.